In this lesson, I'm going to take a look at calculating the volumes of spheres. So we need to first figure out what's the formula to help us find that volume of a sphere. And I'm going to show you one way to calculate that volume, or I'm going to show you where the formula comes from. So what I want you to do is you look at this sphere that I have here, and notice it's been cut up into a bunch of little pyramids, and I've pulled one of those pyramids out. Now, what I'm going to go with the assumption here is that the apex of all of our pyramids is going to be the center of the sphere. So keep that in mind. So what I can do then is go through, and if I could find the volume of all the pyramids, well, if I added them all together, it'd give me the volume of the entire sphere. So my volume is going to equal, well, here we go. So I'm going to take the volume of this first pyramid, the one that's cut out. Well, to find the volume of a pyramid, I know I need to do 1/3 area of the base times the height. Now what I'm going to do is I'm going to call this area of the base 1 for my first pyramid. And then I got to go on, and I'm going to, next, let's say, I'm going to look at this pyramid here, if I were to cut that one out. So if I add that one on, I'm going to take 1/3 area of the base. Now the area of the base of this one is probably different than the area of the base of my first one, so I'll call that the area of the base 2, whatever it is, and then multiply it by the height. And then go on to my next one, which maybe it's this one up here. So now I'm going to add on 1/3 area of the base, and the area of the base is probably different, times the height. Now notice I've always used the same variable for my height, h, because remember, if I really cut these out so that the apex of each pyramid is the center, then the height of every single pyramid is going to be equal in length. Now I'm going to continue on doing this, well, until I get them all out. Well, I don't know how many there are here, so I'm just going to say this pattern is going to continue until I get all the way to my last one, and maybe that last one is when I get to here. We'll just say that's the last one. We've already done all the rest of them. So 1/3 area of the base, and we'll call that n, because I don't know how many there are in there. Not a big deal. I'll show you why in a little bit, and then multiply by the height. Now what we're going to do is I'm going to take a look at this, and I'm going to look at every single one of those terms, and notice that every single one of those terms has 1/3 in it, and every single one of those terms has an h in it. So what I'm going to do is I'm going to factor that out. So my volume now is going to equal 1/3 times the height, and now what's left after I factor it out? Well, I'm going to have area of base 1 from the first term. I'm going to have area of base 2 from the second one, area of base 3 from the third one, area of base 4 from the fourth one, so on and so forth, and until I get all the way to the last one. So we'll call that area of base of the nth term, the last one. Now when you look at this, volume is going to equal 1/3. Well, h, remember we said that that was the distance from the center of my sphere to the, essentially to the base of all the pyramids. Well, that's nothing more than the radius of my sphere. So I'm going to replace the h with an r. And then when I look at all this, that's b1 plus b2 plus b3, so on. Those are the areas of all the bases of the pyramids. When you come up here and you look at this, well, if I look at all of just the areas of all, or if I look at all the bases of the pyramids that I cut out, that makes up the surface of the sphere. So all of this stuff right here is nothing more than the surface area of the sphere. And we already know how to calculate the surface area of a sphere. That's 4 pi r squared. So when everything's all said and done here, I can take this, and my volume is going to equal, well, 1/3 times 4, that's 4/3, times pi, and then r times r squared is r cubed. So you can go back up here, and you can go through and cut out a bunch of pyramids, or you can use this little formula to calculate the volume of any sphere. So all you need to know is the length of the radius. Now what I want to do is I want to find the volume of that same rubber softball that I talked about back when we were looking at surface areas. So I'm going to go back to this fact, and we knew that the circumference of the rubber softball was 30.1 because I measured it using my tape measure. Now remember, circumference equals 2 pi r. So what we can do then, and I did this in the last one as well, but I'm going to do it again just for a little review. Circumference equals 2 pi r. I put in the actual circumference, the 30.1. Now if I go through and I divide both sides by 2 pi, I'm going to be able to calculate the length of the radius. And what I find out is that the radius is equal to 4.79. Well, if I want the volume, I just need to take that radius and plug it into the formula. So my volume equal to 4/3 pi r, which is 4.79 cubed. Now I just need to punch it on my calculator. When I get done punching on my calculator, I find out that the volume of my pyramid, or excuse me, the volume of my sphere is 460.52 cubic centimeters. So what that tells me is if I had 1 centimeter by 1 centimeter by 1 centimeter cubes, I'd be able to fit 460 of them inside of a rubber softball that has a circumference of 30.1 centimeters. Now my next one, I want to find the volume of the sphere. Well, I look at this and say, I know how to find the volume of an entire sphere. Volume equals 4/3 pi r cubed. So if I did that, all I'd have to do then at the end would be just to cut it in half. So that's what I'm going to do. I'm going to look at this and I'm going to say, well, my volume is going to equal 4/3 pi times, now my radius here is going to have to be 5 because the diameter is 10. And I'll have it. Now remember, this would be the volume of the entire sphere. What I'm going to do to start is I'm going to look at the exact value. So my volume would equal 500 pi over 3. So what I did is I took that 5 and cubed it. That's 125. 125 times 4. That puts you at the 500, and then divided by 3. Don't forget to multiply by pi. So there's the exact volume of a sphere with a radius of 5. Now what I need to do is, remember, I need to take that 500 pi over 3 and I need to divide it by 2, or another way to divide by 2 would be to multiply by a half. So if I do that, now what I can look at here is that 2 is going to become a 1, the 500 would become 250, and then all we'd be left with is 250 pi over 3 centimeters cubed would be an exact answer. Now if we wanted to go to the approximate value, we would end up with approximately 261.80 cubic centimeters. So whether you're looking for the exact value here or the approximate value of that hemisphere, we would have it. So remember, take your volume of a full sphere and just cut it in half when you're all done if you're looking for the volume of a hemisphere. And that's going to conclude my lesson on volumes of spheres.